Hello everyone. So today we are going to learn about the widely used topic in statistics and data analytics, that is correlation. We are going to understand the meaning of correlation and then its significance also, and where it is used and all. So let us discuss the agenda for today's session, that is we are going to be starting by understanding what is the meaning of correlation, then positive and negative correlation, that is the types of correlation, and then correlation coefficient, then limitations of correlation, and lastly the real life application of it. So firstly, the meaning of correlation. The correlation is the combination of two words, that is co and then the relation. So co means together, and then the relation means it is a connection between the two quantities. So coming to the meaning of correlation, it basically refers to the technique used in measuring closeness or the degree of relationships between two quantitative variables, which means simply it is used to understand the relationship between two variables or two quantitative variables, and it is sometimes termed as covariance also. Let's see an example here. So if we see a simple example here, it shows that the amount of rain we received and the amount of raincoats that were sold. And what we could do here is measure those things for 20 or 30 days and then plot them in a scatter plot like this, where this is the rain and this is the number of coats that are sold. And then when we plot this thing and see, based on this example, it looks like the relationship is more positive, as there is more rain and there tends to be more sales of raincoats also. And the way we measure correlation is to quantify using correlation coefficient. That is, the measures of the correlation is called as coefficient of correlation, and the correlation coefficient is also denoted by R. So in correlation analysis, we usually want to know two things. The first thing is how strong the correlation is, and the second thing is in which direction the correlation goes to. And the number sequence in correlation coefficient lies between a -1 to +1. The -1 suggests that it has a strong negative, and +1 refers that it has a strong positive thing, and when it comes to 0, it means there is no correlation. And another thing here is you can see what number denotes what type of a relation here in this table. So moving on to the next topic, that is types of correlation. The first type is positive correlation, when it is a relationship between two variables where if one variable increases, the other also increases, and vice versa. That means when x increases, y will also increase. For example, if we take a number of hours that are studied and the marks, so as the number of hours that we study increases, the marks will also increase. That is a positive correlation. And a negative correlation is the opposite of it. When x increases, y will decrease. For example, number of hours that is working, then sleep hours will decrease. For example, the number of hours working is 7, 8, 9, which is increasing, and then the sleep hours will decrease by 8, 5, or say 4. This is a negative impact, right? So this is a negative correlation. And no correlation, there is a third type also, that is no correlation. And in this, where there is no relationship between x and y variables. For example, we can say For example, shoe size and marks, that there is no relationship between these two variables, right? So that is called as no correlation. So coming to the limitations of correlation, correlation does not tell us everything about the data. For example, correlation only measures the strength and direction of a linear relationship between two variables. So it does not explain the actual pattern, cause and effect relationship, or the complete behavior of the data. That is one of the main disadvantages of correlation. And for example, two data sets can have the same correlation value but completely different distributions. For example, a simple real life example can be, suppose we study the relationship between hours spent studying and exam marks and the exam marks. So here we may find a high positive correlation, which means marks generally increase with the study hours. But correlation does not tell us whether studying caused high marks, or whether stress or sleep or teaching quality affected the marks, or whether the few extreme values influenced the correlation. So correlation gives us only the partial information and not the full story. So correlation only indicates association between the variables and does not